Geometry, thanks for tuning in for another episode of Math with Mullins. Today we're looking at 5.6 isosceles and equilateral triangles. Kind of skipping around a little bit for Unit 5, but I promise it'll all make sense in the end. Today we're going to talk about the missing sides and angles of isosceles and equilateral triangles and be able to classify those triangles when we're given side measures and side lengths. The first thing we're going to talk about are the definitions of all types of triangles. So I'm going to go and type those in first, and then we'll draw some pictures. So an isosceles triangle is a triangle with two congruent sides and two congruent angles. An equilateral triangle is a triangle with three congruent sides and three congruent angles. And a scaling triangle is a triangle with no congruent sides and no congruent angles. So now let's draw a picture to show what those look like. An isosceles triangle, in order to know that it's isosceles, is you would have two legs marked with the same tick mark or the same measure. And then you also may have two angles that have the same arc. Notice that the matching angles are opposite from the matching sides. We'll talk more in detail about that later on in Unit 5, but that might help you remember a few things, okay? An equilateral triangle would just mean we would see all three sides are equal, and we would also see the same number of arcs for the angles, okay? And then last one is scaling triangle. That just means we're going to see different tick marks for all three sides, and we will also see different tick marks or arcs. Let me find some. Supposed to have three and different angle measurements for all three angles. Okay? So what we're going to do next is find each measure of whatever's missing here and be able to talk through some of these, and then I'll give you a chance to work on some by yourself. So in number 1, we're going to look for angle J and angle K. Remember, all triangles have a total of 180 degrees for their interior angles. So in this case, I have 180 degrees, and I want to make sure that I am thinking about an isosceles triangle has two matching angles, which means if the bottom right-hand corner is 68, the left-hand bottom corner would also be 68. So the measure of angle J would be 68 degrees because these are across from matching sides, so I'm going to have matching angles that are across from them as well. So to find K, I would just be taking away 68 times 2 from 180, and the measure of angle K should be 44 degrees. Okay? Next up, angle C and angle E are our matching angles. So 106 is the lonely angle. So what I can do here is I'm taking 180 minus 106 and then divide whatever I get from there by 2. Both C and E are going to end up being 37 degrees. And then for number 3, we are looking for YZ. YZ is also going to be considered an isosceles triangle because I have matching angles. So because I have matching angles, I should have two matching sides opposite from those angles. So here and here, which means these two have to be 12. And then to find my missing angle measurement, I'm taking the 77 degrees I have times 2, subtracting that from 180, and I'm going to get 26 degrees for the measure of angle Y. Let's see if you can try 4 and 5 on your own. These are both algebraic reasoning, so see what you can come up with. Let's pause our video for question 4 and 5, and then play it when you're ready to check. So in number 4, this is an isosceles triangle, which means angles are matching. So I'm going to say 5x plus 9 is equal to 8x minus 30. Again, I'm going to focus on moving my smallest variable, so I don't have to worry about too many negatives, and then moving my constant to the other side. So I'm going to end up with 39 is equal to 3x. Divide by 3, x is equal to 13. Okay? And then for number 5, because I see matching angles, that means the opposites should have matching sides. So 15x plus 7 is equal to 23x minus 17. And then moving my smallest variable, 15x, which means my 17 will get moved to the other side. So I'm going to have 8x is equal to 24. And dividing both sides by 8, x will be equal to 3. How'd you do? Let's go ahead and flip over our paper and then do a little bit more of these. So maybe try these on your own as well. See what you can try for question 1, 2, and 3. When you're ready to check it, go ahead and click play.
Please excuse this quick interruption. There will be a Hope Squad meeting tomorrow morning at 7:30. That's Hope Squad students meeting tomorrow at 7:30. Thank you.
Sorry for the interruption. Let's go ahead and get to it. So the measure of angle C can be found by taking 180 and subtracting both of my 60s. So 60 times 2 is 120, minus 80, I'm going to get 60 degrees. From here, you should notice this is an equilateral triangle because they all have the same angle measurements, which means all of my sides, BC and AC, would also have the same length shown for AB. So all sides are 9 feet. And in number 2, because all of my sides are equivalent, they have these same tick marks, this is still an equilateral triangle, which means all my angles are the same. So I can take my 180 and evenly divide it by 3 to get 60 degrees for angle J, K, and L. 3 is an equilateral triangle, so solving for X and Y. What I did here first is, because I knew that they were equilateral, I went ahead and solved for Y, and I just picked 2 sides. So I said 14y minus 59 is equal to 9y plus 1. I'm going to move my smallest variable, add 59 to both sides, and I'm going to come up with 5y equals 60, so that y is equal to 12. Now that I know y is equal to 12, I can focus on x. Since this is an equilateral triangle, that means all angles are 60 degrees. So 7x minus 3 is equal to 60 degrees. Add 3 to both sides. I get 7x equals 63. So that means x has to be equal to 9. And then finishing up here, find the measurement of angle B and angle C. So what I did here first is I made sure of what type of triangle am I seeing here. From B to C, that's going to be 8 units long. And then to get from A to C, I'm thinking about a right triangle. So this is 1, 2, 3, 4. And this one's 1, 2, 3, 4, 5 units. So I'm doing the Pythagorean theorem. 4 squared plus 5 squared is equal to c squared, or 16 plus 25 is equal to c squared. So I'm getting 41. So the square root of 41 is AC, and the square root of 41 would also be to AB. So this is an isosceles triangle, which means if I have 180 and I subtract 70, I'm going to be left with 110, but both of those angles should be matching. So I'm going to divide by 2. So I'm going to get 55 degrees, which means the measure of angle B and the measure of angle C are equal to 55 degrees. The last question, we're classifying DEF by its sides. So what we can do is we can take DE's length and the segment EF and the segment FD and find their distance. So D to E, I did 5 minus 3 squared, and then 5 minus negative 2, which would be 5 plus 2 squared. So this is going to be 2 squared, 7 squared, or 4 plus 49, and I'm going to get the square root of 53. To EF, and I apologize for the bell here, but we're at the end of the school day. E to F, I did 10 minus 5, distance formula for my y's. plus negative 4 minus 5. So this would be 5 squared, or negative 9 squared. So that's 25 plus 81, which is the square root of 106. And then f to d, I'm going to erase these. For f to d, I did 10 minus 3 for my y's. And then for my x's, negative 4 minus negative 2, or negative 4 plus positive 2. So this will be 7 squared and negative 2 squared, which is still 49, plus 4, or the square root of 53. And since I have two matching sides, I'm going to categorize this or classify this triangle as an isosceles triangle. Okay. Hopefully that gives you some encouragement to finish up your lesson on 5.6 isosceles and equilateral triangles. Tune in next time when we start talking about some congruent triangles and how to match matching and corresponding parts. Thanks so much for tuning in, and have a great day. Bye.